Saxon Algebra 2, Lesson 16. Students, we have a one-topic lesson. We're going to review, I kind of squeezed two into one. We're going to multiply and divide polynomials. We're going to remember how to do that. Technically it's two topics, but I'm going to pretend it's one because that always seems better. All right, let's dive in. Multiply, and then John writes the problem like this. In his most unhelpful way. You're copying this down, I know, because you write down everything I write down. I try to go slower, you guys, but I know I'm really bad about that. I get excited, what can I say? Okay, so what John has done is he has given us two polynomials. One polynomial is a binomial, it has two terms, and one is a trinomial, it has three terms. We want to multiply them together. This is one of the reasons why I love the stacking method over what some people learn, which is called the FOIL method. FOIL works fine when it's just your regular, like x plus 3, x minus 2, when it's just a binomial and a binomial. But it breaks down and falls apart when you have this methodology, whereas the stacking method still goes strong. So that's one reason why I prefer it. What we need to do is convert this horizontal presentation, landscape if you will, into portrait. And the way I like to do it is I like to keep the larger one on top. So this one has three pieces. I like to leave that on top. So what I'm going to do is take this and write it underneath left justified. Okay, I'm going to cross that out because I've moved it. I don't want to confuse myself. I don't need parentheses around this anymore. They're just left on there from the way John wrote it because he used those to show multiplication. So I'll leave them, but if I copied this out of the book like you will be doing for your homework, you don't need the parentheses as long as you keep them on different lines. Now, we're ready to multiply. I'm not going to put an X here like we normally do for multiplication because that just looks like another term and that would just cause drama. So, no X's. Remember, this is the dance. The girls are on this row, the guys are on that row. We start with this position, this girl, and she gets to dance with each of the three guys before she sits down and lets this girl take her turn. I imagine an old-fashioned dance studio like in the 30s when kids who were like 12 had to take dancing lessons. Their moms would sign them up for Saturday morning dance lessons, and they would go to some dusty studio with hardwood floors and no furniture, but lots of bright sunlight shining in, and some lovely matronly woman would teach them the finer arts of dancing and good manners. That's what's in my head when I do this, okay? I can see the dust motes in the sunshine of the air. You know how when you can look at dust in sunshine, it kind of twinkles? That's what I always think about when I do this. You guys, my head is a scary place. I just tell you that as a caution. Okay, so the sun is shining. It's Saturday morning. The kids are ready to dance. Ready? 2x times 3x squared. Remember when we multiply this, we multiply the numbers, and then we combine the x's. Because we are multiplying, it becomes 6x cubed. Now she goes over here. The sign, remember, is part of it. So it's minus 10x squared plus 4x. She's done. Sit down, woman, you did well. Okay, now when we start this second girl, her terms are going to line up, usually just like with regular multiplication, that we stagger them, but we don't have to plan that out ahead of time. We can just figure it out as we go. So we multiply her times this first guy. That's 6x squared. We see, oh, we have an x squared right there. So we'll go plus 6x squared. And then here we have minus 10x. And then just a plain plus 4, that can hang out here at the end because we didn't have any plain number terms before. Okay, now this girl has danced. We draw another line, and now we add all of our products. 6x cubed minus 4x squared minus 6x plus 4. That is our final answer. And that turned out to have kind of a fun little 6-4-6-4 pattern, didn't it? Just good fortunes, smiling down on us at a Saturday morning in the dance studio. Okay, that was the first one. Here is the next one. And again, let me just show you. John presents it in an unhelpful format, just like the last one. He writes them landscape next to each other. We don't want that. We want to stack them. So I'm going to put the trinomial on top, and then I'm going to put the x minus 2 justified on the left. And that's the way I want you to do it. Don't copy it out of the book into the format you want. Don't copy John's gibberish. Okay, so 3x squared. I like to leave lots of room so that visually when I start moving my numbers around, I can see the gaps and I don't get, it can all mush together. You guys, all of this is really hard and really complicated. Help yourself by giving your numbers room to breathe on the page, numbers and letters. It makes a difference. And if you can help it, write on the lines. You know what I'm saying? Sometimes I know that some of you, the numbers kind of drift across the page. It just makes it harder on yourself because your eye doesn't see an organized field. Okay, I've got it copied. Remember? Here we go. 3x to the third. Remember, we're multiplying. So x squared becomes x cubed. Minus 2x squared. Minus 2x. And she's done, and it's her turn. And we have minus 6x squared, and I line those up. Typically, this is the way it works. They line up here. But if you ever get one that's wonky, you can write the products down in any order you want. Just make the terms match. Plus 4x plus 4. 3x cubed minus 8x squared plus 2x plus 4. Let's see if I got it right. Yay, I did. In the book, these two problems are kind of equally difficult, and my mind asks, why did we do two examples that are more or less the same? John uses the stacked format in this example, and then he uses a variation of FOIL, what he calls the horizontal method, to do this one. I don't want you to learn the horizontal method. I don't want you to fool around with that. Unless you already know it and you're just continuing to use it, I won't argue with that. But I'm not going to teach you that at all because I think it's just a troublemaker. All right, that's our review of multiplying polynomials. It's the dance. We're now ready to divide. I'm going to flip the page. I just have a feeling that I'm going to need lots of paper for this. All right, so when we divide, again, John writes the problems in a way that is unhelpful to us. We have to change it, but I just want to show you. He writes divide minus 4. Okay, he writes it out as a sentence. His terms are out of order, and we need a division box to make this thing fly. So, again, in your homework life, don't even copy it in this format. Fix it as you write it down. So what I'm going to do is first I'm going to do the division box. That's the first number, the one that goes inside. It's completely reversed, so I'm going to first write it properly. 5x cubed. The minus stays with the 2. Plus 5x plus 2. That goes inside. And then I'm going to reverse the order of this as well. X minus 4. All right, that's the proper way to set it up. You don't have to even write that down. Just do that. All right, then remember the way we do this. It's kind of stilted. What we say is, what do we multiply times x to get the first term, 5x cubed? We ignore this as we do the estimating. Remember, the 4 steps of division are estimate, multiply, I'll write it all out. Estimate, multiply, subtract, and bring down. We're going to use these same 4 steps that we always use in long division. It's the long division algorithm. Hopefully they're burned into your head by now. Maybe not though, long division takes a while. So in our estimating process, we ignore this part of the binomial. We just look at the front and we say, what do we multiply times this to get that? And the answer is 5x squared, right? This will be the third x. Now when we multiply first the x, and sure enough, we get the 5x cubed. And then we multiply the second part, and that becomes minus 20x squared. Now, here comes the tricky part. When we subtract, we put parentheses around the whole thing. We subtract. Now, remember, this changes the sign of both of these terms within the binomial. This one becomes minus, and it cancels from there. You can just draw a line through because that did exactly what it was supposed to do. This turns this into a plus, so we change it, and then we circle it to remind ourselves that this is the final sign. If you don't circle it, then you'll drive yourself crazy trying to remember, did I change the sign or did I not change the sign? Is that the before this minus or is it after? So circle it to tell yourself, I already fixed that. Now we can combine, subtract, but technically we're adding here because it was a negative number, and we get what? 18x squared, right? Beautiful. Okay, now we begin the algorithm again. We estimate. What do we multiply by x to get 18x squared? Okay, 18x, right? We multiply 18x squared minus 4x. Now, I don't mind just looking and seeing that that's up above and quote unquote bringing it down that way, but if you'd like to do this, you can, to get it a little closer to the action. I just save myself the trouble and know that it's up there. But bringing it down is fine. Okay, I subtract. Remember to put the parentheses around. This 18 minus 18, that cancels. This changes this into a plus. I change it, I circle it, and I go, okay, cool. What do I have here? 9x. Okay. I'm looking at the problem in the book, and somehow my answer is looking really different. 5x squared plus 18. Oh, I see what I did. This is wrong. You guys have probably been dying, right? 18 times 4 is what? 72. So this becomes 77x. 18 times 4 is most certainly not 4. That was my mistake. Okay. 18 times 4 is 72, so that's fixed. 5 plus 72 is 77, so I get 77x, and I bring down the plus 2, right? Again, if I didn't care, I could just leave it up there and see it, but I'll bring it down. All right, so now, how many times does x go into 77x? Or, excuse me, that's not the way I like to say it. What do I multiply times x to get 77x? And the answer is 77. 77 times x, 77x. And then 77 times 4 is going to be, let's multiply it. 77 times 4. It's 28 and 28. Okay, so it's 308. So this becomes minus 308. Subtract. This cancels. That turns into a plus, and I get 310. What do I multiply times x to get 310? Nothing. It's not going to work. So I take the final answer and I write it as a fraction. So I take my remainder and write it as a fraction of this part. And that is the correct answer. Crazy, right? We don't use this operation a whole lot. We usually just leave the expressions in fraction form, but if we want to divide down, this is what we can do. And there's one more, and then we're done. And I'm going to write it down in a special way and explain it to you. Let me just show you in the book. Minus 6 plus x cubed by minus 2 plus x. Okay, we recognize right away they're out of order, right? The x terms need to be first. But this one skips from x cubed all the way down to 6. It doesn't have an x squared and it doesn't have a plain x. You remember, these are a little bit of drama, but they're actually not bad. They're not that much harder. What we do is when we set them up, this number inside the division box, we just leave some gaps there. And we'll fill them in when we go. You don't have to think it out ahead of time. You can if you want, once you remember what the secret is. But you don't have to fill those in. Just when you notice that every power of x is not represented, just leave some space. And then on the outside here, I'm going to rearrange this. Instead of minus 2 plus x, I'm going to fix it and put it in the right order. Okay, we use our same algorithm in the same way. What do we multiply by x to get x cubed? Oh, x squared. Now we multiply x times x. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. We subtract just like before. This cancels. Now we realize, shoot, we don't have an x squared term, right? Up here we had every variation in this problem. So here's what we do. We add 0 x squared. That's technically true, isn't it? We don't have an x squared term, and that's the way we can say that. We don't have an x squared term. So we write it in, and now we can actually finish our work. This minus turns this into a plus. I circle it, and when I add them, I get 2x squared. Cool, right? It's a nice little solution to our problem. All right, we begin again. What do we multiply by x to get 2x squared? The answer is 2x. We sure enough get 2x squared, and then we get minus 4x. We subtract. This cancels. And then once again, we see we don't have an x term, so I can add it up here, or I could have done it and brought it down last time either way. But we do the same trick here. We create an x term and just put a 0 in front of it to reflect the fact that we don't have any. We ain't got no x's, you guys. Okay, now I need to change this. See, it's not circled, so I know I didn't fix it yet. (4x). Okay, now I remind myself I do have a 6 here. I'll go ahead and bring it down. But remember that we needed to fill in some gaps, but we do have a term here at the end that we can use in our problem. We go back to the beginning. What do we multiply by x to get 4x? And the answer is 4. 4 times x is 4x. 4 times minus 2 is minus 8. We subtract this. That cancels. That goes plus. We get a 2. What do we multiply by x to get 2? We can't, so we know we're done, and we just create a little remainder fraction. Whatever we have left over the divisor is the technical name for that. This is the divisor, and this is the dividend, and this is the quotient. I don't like those words. I think they're really confusing, so I don't use them very much. That's the final answer. Yay, let me just double check, because I would be so ashamed if it was wrong. That's right. Okay, good job. So if you're not provided with certain terms in the number that goes inside the box, if you will, just add 0 versions of them. Okay, We're done with lesson 16. Yay, we're moving on in the world. Good job, you guys. Farewell.